Hey everybody, and welcome to the next video on proposed answers to the traditional problem of induction. In the past two videos, we've looked at two proposed answers to David Hume's traditional problem of induction: the inductive justification of induction and the pragmatic justification of induction. In this video, we're briefly going to look at a third proposed solution to Hume's traditional problem of induction, the nomological explanatory justification. This is a somewhat more metaphysically loaded proposal than the previous two, but like the previous two, it has some initial intuitive plausibility to it, though it's not, again, like the previous two, not uncontroversial. Okay, let's recall the traditional problem of induction. So remember, this is an argument that David Hume gave that to the effect that scientific inductive logic could never be rationally justified. So we had the first premise: scientific inductive logic can only be justified either deductively or inductively. It can't be justified deductively, and it can't be justified inductively. Therefore, scientific inductive logic cannot be justified, right? And Hume, recall, gave arguments for believing both premise 2 and premise 3 that we looked at in one of the videos from Monday. Okay. Now remember that the inductive justification of induction, or the attempt to justify induction inductively, was a denial of the third premise of this argument. The pragmatic justification of induction and the what we're about to look at, the nomological explanatory justification, are both denials of the second premise. We're trying to justify inductive logic, scientific inductive logic, deductively, with some qualification here in the case of this solution, because we are adding another inference pattern that we'll see as we go along. Okay. So the nomological explanatory solution to the traditional problem of induction is most famously associated with the Australian philosopher David Armstrong and the Oxford philosopher John Foster, both 20th century and 21st century philosophers who died not that long ago. All right, now this sort of argument is also helpfully viewed from the lens of the universe, the uniformity of nature that we discussed when we're talking about the pragmatic justification of induction. So recall that we might have hope for justifying scientific inductive logic if what we call the principle of the uniformity of nature holds, right? That is, if nature is regular or uniform, right? The patterns that are exhibited in the observed parts of nature or in the past are also exhibited in unobserved parts in the future. Because if that was the case, then if nature were uniform, then scientific inductive logic would arguably be reliable, because the predictions it would make from observed to unobserved cases would turn out to be successful predictions, right? So it would be reliable or successful or rationally justified in the sense of our original suggestion for rational justification, what we called suggestion 1. So what the nomological explanatory solution wants to do is argue that scientific inductive logic is reliable through nature being uniform. Right? So we have a simple sort of argument like this: if nature is uniform, then scientific inductive logic is reliable. Nature is indeed uniform, thus scientific logic is indeed reliable. So this is a deductively valid argument. The key thing here, though, is going to be justifying premise 2, right? And this is where the nomological explanatory solution really comes into place in trying to give us an argument for why we should think that nature is indeed uniform. All right, so that's what the proponent of the nomological explanatory solution is going to try to do, is supply a good argument for premise 2, a good reason for thinking that nature is uniform. So the way that they do this is to employ an inference known as inference to the best explanation, right? We'll see an example of this on the next slide, but the basic straightforward sort of argument they then give for nature being uniform is something like this, right? Nature has been uniform in the past, right? Therefore, nature must be uniform, right? So we see that in all the past observations, nature has been uniform. We then think that calls out for some sort of explanation. So we're like, well, what could explain the past uniformity of nature? Well, maybe it's something necessary. Maybe nature has to be uniform in that way because there are certain laws of nature that govern it and require it to be that way. right? So consider a sort of example. So suppose that I drop a coin 100 times and it falls to the ground every time I do so. Even though there's an infinity of different directions that the coin could fly, it always goes straight down to the earth. It's natural to think that that sort of regularity calls for explanation. The fact that 100 times in a row, it always fell down, right? And in combination with the rest of data we have about the workings of the universe, you might think the best way to explain that is through positing laws of nature. For example, Newton's law of gravity, or in more modern incarnations, maybe Einstein's theory of gravity, right? We take these laws of nature, or these ways that the universe supposedly has to work, to provide an explanation for the way it does work, at least in our current or past observations. And then once we have those laws of nature on board, once we grant that there are laws of nature which compel nature to be uniform, we can derive deductively that nature is generally uniform, past, present, and future, and hence that scientific inductive logic will therefore be reliable. Right? So note here that we're tweaking a bit the concept of rational justification that we had in suggestion 1. Right? So remember, our suggestion 1 for what it was to rationally justify scientific inductive logic was that a system of logic we said was rationally justified if and only if it can be shown using just our stock of knowledge that the arguments to which it assigns high inductive probability yield true conclusions from true premises most of the time. This is what we've been saying, what we've been describing as being reliable, right? So we've been saying, right, that for a system of logic to be rationally justified is for us to be able to show using only our stock of knowledge, right, that it is reliable. The tweaked suggestion, which we call suggestion 4, here is that a system of logic is rationally justified if and only if it can be shown using our stock of knowledge and allowing ourselves IBE, or inference to the best explanation, that the arguments to which it assigns high inductive probability yield true conclusions from true premises most of the time, right? So this is a sort of weaker notion of rational justification, sort of like in the case of the pragmatic justification for induction. We weakened our notion of rational justification to argue that we could justify scientific inductive logic. We're doing a similar sort of thing here, although it's a very different sort of weakening, right? And it's a weakening that keeps fairly close to the original notion of rational justification, except now we've introduced the allowance for IBE. However, if we're being honest, right, this is not going to give us a purely deductive justification of scientific inductive logic, because IBE, or inference to the best explanation, is not a deductively valid inference pattern. So we have to end up assuming at least one proposed rule of scientific inductive logic, IBE, in order to justify the rest of scientific inductive logic, right? So we've ultimately not succeeded, then, it would seem, in justifying all of scientific inductive logic, right? Which is what we wanted to do with suggestion 1 of what it was to rationally justify scientific inductive logic. At best, we've justified part of scientific induction on the basis of another part, inference to the best explanation. The defenders of the nomological explanatory justification realize this, and they're okay with this, because they think that the justification for IB is just basic, right? They don't think it's something that stands in need of further argumentation or defense. But that's at the very least something you might worry about, right? So it seems like we at the very least don't have a full justification of scientific inductive logic, regardless of whether we think this is a helpful or adequate account that the defenders of the nomological explanatory proposal have offered. Okay. All right. So by this point, we've looked at 3 different proposals for how to respond to David Hume's traditional problem of induction. Each one, I think, has some intuitive plausibility behind it. So there was the inductive justification of induction, right? The thought was that why is scientific inductive logic justified? Well, because it's worked well in the past, right? The worry there was that it was circular. That sort of reasoning was circular. And we saw that there were some sophisticated versions of this justification that ended up not being circular, but nonetheless had other problems with them. For example, they could be used to justify crazy systems of inductive logic like counterinduction. Right? We also looked at the pragmatic justification for scientific inductive logic, right? This proposal said we need to tweak what we mean by rationally justifying scientific inductive logic. Instead of what it is to rationally justify scientific inductive logic being that we need to show that it's reliable, instead what we need to do is show that it's optimal. That is, show that if any system of inductive logic does well or is reliable, then so too will scientific inductive logic do well or be reliable. So this was a fairly good notion of rational justification, but it's not clear that the proponent of the pragmatic justification actually proved this, actually demonstrated that scientific inductive logic met that criteria for rational justification. And thirdly, the nomological explanatory justification said, well, why is scientific inductive logic good? Well, because we make an inference from the fact that it's worked in the past to things like laws of nature, or that the world has to be uniform in a certain way, and then use that to deductively justify scientific inductive logic and its reliability. This, however, right, required us to assume that inference to the best explanation, a certain sort of inference pattern of plausibly scientific inductive logic, was reliable. So we at least had to assume one part of scientific inductive logic, even if that did in fact help us justify the rest of scientific inductive logic. Right. So each of these three has some intuitive plausibility to it. They each have far more sophisticated versions, as I mentioned earlier, that I encourage you to look at and read more about, for example, on the Stanford Encyclopedia entry for the problem of induction. But we've at least seen that there's no, among these three, and in general, no totally non-controversial solution to this problem. So it's something that's worth continuing to think about. If you're interested in philosophy, maybe it's something to think about writing on. But for our purposes, we'll close our initial investigation of the traditional problem of induction here, and we'll begin in the subsequent videos to look at what's called the new problem of induction, where we're going to look at that notion of what it is for nature to be uniform and see that it's not quite as clear what that means as you might think from just our simple use of that language in these videos so far. All right, so thank you for watching, and please complete the participation poll for this video, and I'll see you next time.